What is the condition for two or more lines to be parallel? In the previous two tutorials, 14.2 slopes and gradients and 14.3 equations of linear graphs, we explained the concept of gradient, which is a mathematical representation of the steepness of a linear graph. Given this, it is evident that two parallel lines have the same steepness, and therefore, the same gradient m. On the other hand, since the graphs do not pass through the same coordinates, they have a different y-intercept. This means the constant n of their corresponding equations is different. Otherwise, the lines would not be parallel but convergent. From the above reasoning, we conclude that the equations of two parallel lines L1 and L2 are, for L1, we have the following shown on screen. And for L2, we have the following shown on screen. For example, for the lines we have the following shown on screen. And we have the following shown on screen. Are parallel, as the gradient is equal in both lines, m equals 2, but the constant n is different, in the first line, n equals -1 and in the second line, n equals 3. The following figure shows both lines in the same graph. We have the following shown on screen. Example 1. Find the equation of the line L1 with equation y equals mx plus n, if it is parallel to the other line L2 with equation y equals -2x plus 3 if the first line, L1 passes through the point A, 1, -2. Solution 1. Since L1 and L2 are parallel, they have the same gradient, m equals -2. Therefore, the equation of L1, we have the following shown on screen. We have another clue given, point A, 1, -2, which belongs to L1. This means we can substitute x equals 1 and y equals -2 in the relation to find the complete equation of L1. We have the following shown on screen. Therefore, for the equation of the line L1, we have the following shown on screen. Or simply, we have the following shown on screen. We can find many more things about parallel lines besides the equations and/or orientation. Let's consider another example. Example 2. The distance between the x-intercepts of the parallel lines L1 and L2 is for units, L2 is more on the right. For the equation of L1, we have the following shown on screen. And for that of L2, we have the following shown on screen. A. Calculate the value of the gradient m for the line L1. B. Calculate the value of the constant n for the line L2. C. Calculate the distance between the corresponding y-intercepts. D. Plot the two graphs in the same coordinate system. Solution 2. A. Since L1 and L2 are parallel, they have the same gradient. Thus for the first line, we obtain the value of gradient m equals 2. In this way, for the equation of the first line L1, we have the following shown on screen. B. The x-intercept of L1 is obtained by substituting y equals 0 in the first equation. Thus, we have the following shown on screen. Given that the x-intercept of L2 is for units on the right of that of L1, we have for the x-intercept of L2, the following shown on screen. This means the point Q, 1, 1/2, 0, is a point of the second line L2. Substituting these coordinates in the equation of L2, we have the following shown on screen. To obtain the value of the constant n, i.e. we have the following shown on screen. This means that line L2 has the equation. We have the following shown on screen. C. Since the y-intercept of a line has the value of the constant n, and given that the constants of the two lines L1 and L2 are -3 and -11 respectively, the distance between the two t-intercepts is 8 units, because we have the following shown on screen. The negative sign means that L2 is below L1. D. We already know all intercepts with the axes. Thus, for the line L1 we already know 2 points, Q, 3/2, 0, which is the x-intercept, and P, 0, -3, which is the y-intercept, while for L2 we have two other points given, S, 1/2, 0, which is the x-intercept, and R, 0, -11, which is the y-intercept. Therefore, we plot the graphs based on these 4 points, as shown in the figure. We have the following shown on screen. It is easy to see that the two lines are parallel, as expected. That is all for lesson 14.4.2. To continue this tutorial, please watch 14.4.3, Perpendicular Lines. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.com.